Hey guys, this lesson is going to look at how to write systems of equations from word problems. And so by the end of this lesson, you should be able to write and solve systems of equations from those word problems. Now, I say write and solve. We're not actually going to solve these using substitution or elimination. We're going to just use Desmos for the solving part. But you need to be able to write and solve the equation from a word problem. You're going to see some of that in your state test, and so we want to make sure that we are prepared for that. You also see quite a bit of that, or some of that, on your ACT, so it's pretty common to see those kinds of questions. So let's go ahead and jump right in. So writing a system of equations is going to be a lot like writing your normal equations, like we were doing in the past couple of lessons. But instead of writing a normal equation, you're going to be writing two equations, but they're still going to be linear. So they're still going to be either in slope-intercept form or in standard form, but you've got to be able to write two. So the first thing we do is we identify what our two variables are going to represent, because usually identifying the variables will kind of help you see how your equation needs to be set up. Then you're going to break your problem apart to see what information goes together. Usually that looks like maybe all the information about one particular thing together, or the information about all the money goes together, the information about all of the or a certain person's stuff goes together. You'll kind of see how that breaks apart in these equations. So we need to be able to do that. Then we also need to then create our two equations using that information that we were able to kind of break apart, and we put that into Desmos to graph them and solve them. So start out by writing the equations and then look at how we can put it together to graph it and solve it. So equations we know can be written in two forms, and this is kind of a refresher of what we did in the lesson on just writing linear equations. So we have slope-intercept form that we know is our y equals mx plus b. This is used when you're given a slope and a y-intercept, or an initial value, sometimes they call it that, or in 2 points. So this is typically a situation where you are not given a total. You're usually trying to find a total for this. And then standard form, that's your ax plus by equals c. That's when you're given two rates, or two slopes, really two rates, and a total. So if the question asks you to find a total, then you're probably writing one in slope-intercept form. If the question asks you to find the parts, then you're probably writing in standard form. Not always, but usually. It's kind of an easy way to give yourself a hint of what you're trying to do here. So if you're finding the parts, you're writing in standard form. If you're finding a total, one of your variables is going to be your total, then you're going to be writing in slope-intercept form. All right, and the rest of this is going to be examples, because that's about the best way we can get good at this, is just to keep looking at different scenarios and practicing how to write those different things out. So, first one, this one is a really simple one. It says, find the value of two numbers if their sum is 12 and their difference is 4. So first thing we got to think about here is, okay, we're looking for two numbers. That's what my variables are representing. Thing we're trying to find. So the two numbers are going to be x and y. It does not really matter which one is which. So it says, find the value of two numbers if their sum is 12. That's one thing it tells me. And another thing it tells me is that their difference is 4. So I'm going to write two different equations, one that shows a sum of 12, one that shows a difference of 4. Now we know the word sum means to add. So the first equation would look like me adding the two numbers together to equal 12. We know the word difference means to subtract. So the second equation will show me subtracting the two numbers to equal 4. And then you can graph this in Desmos, find the point of intersection and solve it. Or some people in first block today just said, well, I know what this is because 8 plus 4 is 12 and 8 minus 4 is 4. That's great. If you can do that in your head, more power to you. It's absolutely fine. So the solution to this is 8 4. And you could see that if you graphed it in Desmos, it would show you that point of intersection, which means those two numbers are 8 and 4. All right, let's look at a more complicated one. Miss Felton has asked for help assembling Valentine's treat bags. Jody has already finished assembling 8 treat bags when Michaela, sorry, I put the word "the" in there, wasn't intentional. When Michaela came into the library to help. Jody assembles at a rate of 2 bags per minute. In contrast, Michaela works at a speed of 3 bags per minute. Eventually, they'll both have assembled the same number of treat bags. How many treat bags will each have made, and how long will that take? So we've got to start out by figuring out the 2 things we don't know. So the 2 things we don't know here, and the 2 things they ask us to find that our variable will represent, is how many treat bags, number of treat bags, and how long. So we have a number of bags and we have time. So to decide which one is our x and which is going to be our y, we want to look for a rate. So we actually have 2 different rates here too, which we should, because we're going to have 2 different equations. But we have Jody's rate of 2 bags per minute, and then we have Michaela's rate of 3 bags per minute. Now we know that a rate is a slope, and it's always the y per the x. So when I read that rate at bags per minute, that means bags has to be my y, and minutes, time, has to be my x. So when I write these equations, my total number of bags is going to be the y value, and how much time passes by to make that happen will be the x. So when you go to write an equation for something like this, you want to think about, especially if there's 2 different people, you're almost always going to write one equation for one person and one equation for another. So if I write an equation to represent Jody, this problem tells me that she assembles at a rate of 2 bags per minute. So the number of bags she does will be equal to 2 bags per minute. And then I can do the same thing with Michaela. So Michaela assembles at a rate of 3 bags per minute. Now, this is not all the information they give me. If I graph these 2, I would end up with lines that cross in kind of a weird spot, I think. Let me see what. We end up with lines that cross at 0, which doesn't make sense because obviously you're not making 0 bags. You're not going to spend time doing that. So the additional information they give us is this idea that Jody already did 8. So in my equation for Jody, I need to make sure I represent that. Jody already finished 8. So if she's already got 8, that's her initial value. That's her y-intercept. She starts with 8. And then we have Michaela's value there that we can use to finish solving this. So when we solve this, again, you can graph this in Desmos, and I'm not going to pull Desmos up to show all of these because we know how to do that already. But if you were to graph this in Desmos, it's going to cross at the point 8, 24. But we need to be able to interpret that point for what it means in this problem. So when I think about that, and this is kind of why we label our x and y, we know that x is time and y is treat bags. So this point 8:24 tells me it takes 8 minutes for them to make 24 treat bags. You need to make sure you know what each part of that point represents, because the questions on the test will not be what's the point of intersection for this. It's going to be how many treat bags could she make, or how much time does it take her. It's going to be specific things to that, and you've got to know which part represents what so you can get the right answer to those kinds of things. All right. Let's take a look at this one. This is a pretty common type of question. Antoinette's school is selling tickets to a musical performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child's ticket for a total of $38. The school took in $52 on the second day by selling 3 senior citizen tickets and 2 child tickets. Find the price of a senior citizen ticket and the price of a child ticket. So again, we've got this scenario. We know we're looking for 2 things. We're trying to find the price of a senior ticket, and we're trying to find the price of a child ticket. So that's my 2 unknowns. Now let me go back up here to the rest of this problem and see if I have a slope that I can use to tell me which one needs to be X and which one needs to be Y. So it tells me up here, on the first day of ticket sales, the school sold a total of 3 senior tickets and 1 child ticket for a total of $38. This is not a slope-intercept statement. This is going to be a standard form statement because it gives me a total. So it doesn't matter which one I let be X and Y if I don't have a slope in the problem. So the price of a senior ticket we can let be X, and the price of a child ticket we can let be Y. And then we can solve this. If you decided to reverse that and let the child ticket be X and the senior ticket be Y, you still get the same answers. Your point will be backwards, but what your point says will still be the same. So if I take that first sentence there and I write an equation with that, because we have a total, we know that our equation is going to equal $38. And I'm going to go and find the rest of the information on that to create this. So it tells me that $38 came from selling 3 senior tickets and 1 child ticket. So I can call that 3X, because I let X be senior tickets, plus 1Y, 1 child ticket, to equal 38. Now, you don't have to put a 1 with the Y. It's not wrong if you do. It's not wrong if you don't. But you need just a plain Y or 1Y there for that first statement. And then the second sentence for the second day tells me that their total was $52. So I know my second day equation is going to equal 52. And that $52 comes from 3 senior tickets and 2 child tickets. So 3 senior plus 2 child. And then again, we can graph that in Desmos to find our solution to it. And we find that a senior ticket costs 8 and a child ticket costs 13. I think that was right. 24 plus 26. Oh, it might have been 14. Hang on, I don't actually remember the answer to this. I was hoping my brain was working, but it may not have been. 3X plus 1Y. Must be 14. Did I say 14? I said 13, but I think it's 814 actually. Let's check it and make sure. So 3. Hello, Desmos. Be nice to see you today. 3X plus Y equals 38. 3X plus 2Y equals 52. And they cross right there at 814. Sorry, I said 13, but it's 14. 814. Okay. Let's do a few more together, and I'm going to let you try a couple. Emma is shopping for a cell phone plan. She's trying to decide between AT&T and C Spire. AT&T offers a plan with a $20 monthly fee plus a charge of 5 cents per minute. C Spire offers the same plan with no service fee, but they charge 15 cents per minute. At what number of minutes will both plans cost the same amount? So I'm going to start with trying to figure out what 2 things I don't know. I don't know the number of minutes. They asked me that. At what number of minutes will both plans cost the same? So I don't know how many minutes. I also don't know the cost. I know that it has to be the same, but I don't know the cost. So that's going to be my 2 variables, my X and my Y. Again, to decide which is which, first look and see if there's a slope. So if you go back up there to the problem and you read, we've got information about AT&T and we have information about C Spire. So we're really going to have an equation for AT&T, and then we're going to have a second equation for C Spire. And in both of those, the slope, remember, is the one with the word per, is something per minute, some amount of cents per minute. So it's got to be a Y per an X, which means minutes has to be X, and the cost has to be Y. So when I go to write my equations, I'm going to write one for AT&T. I'm going to write one for C Spire. So for AT&T, the cost of that plan is going to be equal to the slope, mx plus b, remember, 0.05x plus a $20 service fee. Now, to go with C Spire, they charge no service fee, but they charge 15 cents per minute. So my total there will equal 0.15x plus nothing. I don't have to have a plus b or an initial value here because there is no initial amount for that. So then we can graph that in Desmos and find our answer. Or I just happen to remember the answer, sort of, we just calculated anyway. But if you graph that in Desmos, it would cross at 200, 30. So what that point means is that the x value is 200 for my situation, and the y value is 30. So according to what I labeled here, 200 is minutes, 30 is dollars. So for both plans to be the same, they would have to use 200 minutes, and that cost would be $30. So we've got one equation for each. This is this is the same kind of question like the Jody and Michaela question earlier. If you've got two different people or two different companies and you don't have a total, they don't give you a total, you're going to be writing y equals equations, one for each one. All right, let's look at this one about Brooklyn. Brooklyn owns 2 hotels and is ordering towels for each. She bought 83 hand towels and 81 bath towels for her hotel in Meridian, spending a total of $980. She also ordered 23 hand towels and 59 bath towels for her hotel in Hattiesburg, spending $564. How much does each towel cost? So let's identify what we don't know, the thing our variable will represent. They're asking us to find how much does each towel cost. So that means our x and our y are going to be cost of towels. Oops. So we'll let x be hand towels, and we'll let y be bath towels, so we can keep that straight. All right. So when I look at this, I see that it naturally breaks down into one statement about what she spent at her Meridian hotel and one statement about what she spent at her Hattiesburg hotel. So I'm going to write one equation for the Meridian one because I have a total for that. And I'm going to write one equation for her Hattiesburg one because I have a total for that. So for the Meridian one, I know that she bought 83 hand towels, so that's 83x. Plus, I don't know what I did. Plus 81 bath towels, so 81y, to equal her total of $980. And then at the Hattiesburg one, she bought 23 hand towels and 59 bath towels to give that total of $564. So those two equations represent one for Meridian, one for Hattiesburg. I have those two totals, and so I put together what created those totals, and that's going to allow me to find my solution to this. I don't remember the answer to this one. Might be 4 and 8. I might be wrong. So we'll just do it. So 83x plus 81y to equal 980. And then 23x plus 59y to equal 564. Oh, looks like something happened. 564. Okay, that's better. And so 4, 8 is my answer, which is kind of what I thought, but I couldn't remember. So 4, 8 is that point of intersection. So again, let's interpret what that means. This tells me that the cost of a hand towel is $4. $4 per hand towel. And the cost of a bath towel is $8. All right, let's look at a couple more, and then we'll let you try a couple. All right, Dylan and Nathan are selling fruit for a school fundraiser. Customers can buy small boxes of oranges. Let me try again. And large boxes of oranges. Dylan sold 3 small boxes and 14 large boxes for a total of $203. Nathan sold 11 small boxes and 11 large boxes for a total of $220. Find the cost per box for small boxes and large boxes of oranges. So if you feel like you're ready, you can pause the video right here and see if you can get this right. But if you want me to walk through it with you, then that's fine too. We can walk through a couple more together. But this one asks us to find cost per box for small and large oranges. So that means I'm going to have X for small, Y for large. Now this one is a lot like the last one that we did because we've got 2 different people, and so we're going to write 2 equations to represent each of those people. So I'll write one equation for Dylan using his total, and then I'll write a second equation for Nathan using his total. So if Dylan's total was $203, and in that $203, he sold 3 small boxes, and small boxes are X, plus 14 large boxes are Y. That's going to give me a total of 203. And then for Nathan, I can do the same thing. He sold 11 small boxes and 11 large boxes to make his total of 220. And so I can get an answer to that just by graphing that in Desmos and finding our point of intersection, which I, again, don't remember what it is. I think it's something like 7 and 14 or something. Anyway, 3x plus 4y equals 203. And then 11x plus 11y equals 220. All right, so I'm going to find their point of intersection. It's not 4y. It's 11y, isn't it? What is it, 14y? 14, not 4. I'm like, something's wonky about this too. Sorry, y'all. 14. There we go. 713. So 713 is my solution. And again, I'm going to interpret that. That solution tells me that it's $7 for a small box and $13 for a large box. All right. Yeah, we'll do one more together, and then we'll let you try a couple of these. This one's a little bit different. Tessa and Brianna are running a concession stand at a basketball game. They are selling hot dogs and sodas. Each hot dog costs $1.50, and each soda costs 50 cents. At the end of the night, they made a total of $78.50 by selling a total of 87 hot dogs and sodas combined. Okay, sorry, got interrupted. I think I was at Tessa and Brianna must report the number of hot dogs sold and the number of sodas sold, how many hot dogs were sold, and how many sodas were sold. So just like we've done on the other ones, we're going to take this and we're going to find the two things that we don't know. So we don't know how many hot dogs and we don't know how many sodas. So we'll let that be our X and our Y. Now, when we read the upper part of this is going to set up differently because they don't show us like only information about one thing or only information about another thing. They show us all this about each hot dog cost this, each soda cost that, and the night they made this, and they sold this many items. And so we have a lot of stuff that's kind of mixed up here. If you have a question like this, but you notice that they give you two totals, which is what this one does. They tell us a total of 78.50, and they tell us a total of 87 hot dogs and sodas. You're going to set this up with an equation for both. So I need one equation that equals our 78.50, and I need another equation that equals the 87 hot dogs and sodas combined. So when you go to put this together, the one that involves money needs to involve everything money related. Anything that goes in to create that total of 78.50 has to go in that equation. So if they tell you that a hot dog costs $1.50 and a soda costs 50 cents, that information has to go into that equation about money. So since we know X is hot dogs and Y is sodas, we're going to put all that together as $1.50 per hot dog plus 50 cents per soda to equal our 78.50 total. So that one's not too bad. Most people are able to come up with that pretty easily. But then what about the second one that has to equal 87? 87 is not money. So using the $1.50 and the 50 cents doesn't apply to that one because there's no money involved in the 87 items. It's just a number of items. But the problem doesn't give us any other information. And really, they don't give it to us because we don't have to know it. All we have to know is that this 87 items is hot dogs and sodas together. So if X is hot dogs and Y is sodas, I can add X plus Y to get that 87. And then just like we've done with the rest of them, we can take that, graph it in Desmos, and find our point of intersection. So 150. So that means I'm going to take my 150X plus my 50 cents Y. And then my X plus Y equals 87. And I'm going to find that point of intersection. So they intersect at 35.52. So that's my solution, 35.52. So let's interpret that again. So 35 is my X. We said earlier that X would represent hot dogs. So that means they sell 35 hot dogs and 52 sodas. All right, I want you to take a minute, and there are 3 questions that say you tried at the top. So pause the video right here and take a minute to try those next 3 that say you try it. And then when you're done, come back and see if you got them correct or not. But please pause the video and really try to set them up. The only way to get good at this is to practice it. So pause the video, try setting those up, get a solution from Desmos, and then come back and see if you were correct. All right, take a look at these and see if you got correct answers for them or not. So this is the system I set up for this first one. It said different, so I used subtraction. It said sum, so I used addition. And then when I graphed that in Desmos, I got a point at 8.5. We don't have to interpret this point because it's just 2 numbers, so it doesn't really matter. We just have 8 and 5. A lot of times the questions on this will be something like, which is the larger of the 2 numbers? And you would answer 8. Sometimes they'll ask for the whole point, but they might ask for stuff like that as well. Or they might even say, what is the difference between the 2 numbers? And so just be able to answer those kinds of things, create the system, find the solution, and then see what they're actually asking you to do with those solutions. Say that. The next one about Mr. Landrum, you had to set up two different equations for each company. So when you have two different companies, you've got two different slope-intercept form equations. So we wrote one for Cillian's company and one for Culpeper. And then we solved that in Desmos and got 14,210. And so I interpreted that as 14 DVDs would cost $210 from both companies. All right. And then this one, I made one equation for Jordan's order and one equation for Teresa's order. And then when I solved that, I found the cost of tacos and burritos to be $1.25 and $2.50 each. All right, now there are 3 questions left that are test prep questions. And so I'd like you to take a few minutes with these and also see if you can go through, read the information that's given and answer those 3 questions, and then come back and see if you were correct. Okay, so take a look at this one. If you set this up correctly, you would have written one equation for the cost of the ice cream, and then another equation for the total number of items. So this one is a lot like the concession stand question from earlier. And so the system that you should have written is like this, and it doesn't matter the order that you wrote it in if you did this one first and then this one next. But they should both have these 2 different totals. The one with money gets the 2 and the 350. The one with the total number of items just gets X and Y. And then if you graph that in Desmos, you end up with A as your answer choice. Now, I eliminated B and D before I even tried this in Desmos because 15 plus 16 would have equaled 31 items instead of 30, and 18 plus 14 would have been 32 instead of 30. So I knew already that that couldn't be it. And then I went with my other options to see which one was correct. In this one, this was a little bit different too. We get this equation for Desiree's total, and that one's pretty easy to come up with, but then figuring out the second equation is a little bit tougher. But since they tell us that a cookie is $1.25, I can say that X's would equal $1.25, and I could graph this. Or you might have instead just done 12 times $1.25 plus 8y equals 33 and solved that. That's absolutely fine too if that's what you did, if you didn't recognize it as X equals 125. Or you might have done some other kind of mathy way of figuring that out, but you should have gotten D. Which with whatever method you use. You did not have to use a system for this. There were other ways you could have gone about it. But this is the system if you wanted one and created one. All right, and then the last one. So this one gave me 2 different totals, and so I wrote 2 different equations, one for Saturday and one for Sunday. And then when I got my point of intersection, it was at 10.25, 875. And so they asked for the cost of a calzone, which would have been the Y value for this one, which is why my correct solution here should be A. The 875 was the calzone cost. So A was the right answer to that one. All right, that's the end of that lesson. There's a graded practice assignment for you in Canvas to work on, but make sure you submit those notes before you start that. Have a wonderful day.